Hello everyone and welcome back. My name is Mr. Covalt, and in this video we're going to go over how to find the K value, the equilibrium constant value for a reaction. In this case we're going to be looking at the vaporization of water. So let's get into this. Okay, so for this problem we're told the vapor pressure of water at 25 degrees Celsius is 23.8 millimeters of mercury. And they ask us to write the K for the vaporization of water in the unit of atmosphere, and then they ask us what the Kc of the vaporization process. So basically they're first asking us to give the Kp value and then give the Kc value. And so again, the K value that we're thinking about here is the equilibrium constant. So the process that we're looking at is the vaporization of water. So let's write that down. So we've got the vaporization of water. Basically that is water, H2O in the liquid form being converted into water in the gas form like so. And we want to find the K value for that. So the first thing we need to write down is the expression for K. And so the expression for K generically is the concentration of products over the concentration of reactants. Let me write that again, reactants. Okay, so that's a simplistic, simplified, generic version of what the equilibrium constant expression is. So the other thing we need to remember is that liquids and solids do not go into your expression because they're really, concentration doesn't really change with liquids and solids. So we're not going to include liquid water. So basically, we have the product of water vapor. And so in this equation, the K expression is basically going to be the partial pressure of water vapor, right? So this is going to be our Kp. That is why they're asking us to write this K value in terms of atmospheres. So they gave us the partial pressure of water vapor at 25 degrees Celsius in millimeters of mercury. Since Kp is equal to the partial pressure of water, therefore that's it. So Kp is equal to 23.8 millimeters of mercury. However, they want us to write that in terms of atmospheres. So all we need to do is convert to atmospheres. So we'll take the 23.8 millimeters of mercury. We know that 760 millimeters of mercury is equal to 1 atmosphere, so we'll use that. So 760 millimeters of mercury on the bottom, and then 1 atmosphere on top. Millimeters of mercury cancel out, and then when we do that, we calculate 0.03132, 0.03132 atmospheres. And since we have 3 sig figs here, then technically we would limit this to 3 sig figs. So the final answer would be 0.0313 atmospheres for that. Okay, so that would be our Kp value. The Kp is equal to this in atmospheres. But they're also asking us what is the Kc for the vaporization process, or the vaporization of water. And so there's an equation that we're going to need to use that's pretty helpful. And that equation is that Kp is equal to Kc times RT, and that is to the delta N. And delta N here is, N as we know, refers to moles. So the change in moles, that is defined as the moles, the gaseous moles of products minus the gaseous moles of reactants. So again, that's what that is. So that delta N is the total number of moles of products in the gas phase minus the total number of moles of reactants in the gas phase. And so we can use this to help us convert our Kp to Kc by rearranging the equation and solving. So we'll get into that. And so here we go. So let's erase this, give us some space here. So here we know that Kp is 0.0313 in atmospheres. So let's go ahead and write that. So we have 0.0313. 2. We'll add an extra digit. We'll keep the 2 here since we're using it in the calculation. And we don't want to run into a rounding error. And so that's going to be equal to Kc. And that's multiplied by R. And that's going to be your R value. Let me get my space here. So that's 0.08206, and that's liter atmospheres over mole Kelvin. And then we're going to multiply that by temperature. And in this case, temperature is 25 degrees Celsius. It should be in Kelvin, so we're going to have to add 273 to that, right? So I'll write it down here. So 25 degrees Celsius plus 273.15 is going to give us 298.15. So we're going to add that, so 298.15 Kelvin. Okay, so let's put that under square brackets because then we're going to have our delta N. Okay, so I need my delta N here. Right, what's delta N? So delta N, as I said, is the gaseous products minus gaseous reactants. So it's the moles of gaseous products minus the moles of gaseous reactants. And you'll notice here I don't have any gaseous reactants, so it's 0 moles of gaseous reactants. And here I have 1 mole of gaseous water, so there's a 1 in the coefficient. So it's basically delta N, if I write it down here. So delta N here is going to be products minus reactants. So I have 1 mole of products minus 0 moles of the reactants. And again, we want gaseous reactants, not liquid or solid. So that's going to be 0 on this side. So basically 1 minus 0 is 1. So this becomes 1. Okay, so now all I need to do is just multiply and divide. So basically, this is going to be all divided. So I divide this by 0.8206 liter atmospheres over mole Kelvin. And I'm going to divide by 298.15 Kelvin here. And I'm going to divide on this side as well. So it's going to be divided by 0.08206 liter atmospheres over Kelvin mole. And also divided by 298.15 Kelvin. Okay, so all of this cancels out. And then let me erase all of this so that I don't need this anymore. So now Kc is equal to all of this. So if I calculate this now, before I calculate, notice that the atmospheres here cancels out and Kelvin here cancels out, and I get liters over moles on the bottom. So this is 1 over this. So this is all on the denominator. So liters over moles in the denominator becomes moles over liters when you bring it to the numerator. And so I get a molarity unit, which is what Kc is. So Kc is going to be equal to whatever this is. So if I calculate this, I get 1.28 times 10 to the, what I get? To the -3. 1.28 times 10 to the -3 molar. So that's the Kc value for the vaporization of water. And that, ladies and gentlemen, is how you do it. I hope you enjoyed this video. If this helped you in any way, if you enjoyed the video, if you liked the video, hit the like button over there. Also, make sure you subscribe to my channel. Help me out. Hit that notification bell up there. And when you do, click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.